In this video, we're going to take a look at MathCounts Warm-Up 2 from the 2018-2019 problem set. Number 41. If the value of x is 10, what is the value of 3x plus 4x plus 5x? Well, let's combine like terms. 3 plus 4 plus 5 is 12, so this adds to 12x. And if x is 10, 12 times 10 is 120. I'm surprised that's a two-star problem. Let's say that's a one-star problem. Come on now. Number 42. In the figure, two regular pentagons have been attached to a regular hexagon to create a 12gon. If each resulting polygon has side length 3 feet, what is the perimeter of the resulting 12gon? Well, when they say regular, that tells you that all the sides are the same length. So, saying that all these sides are 3. And our final shape is a 12gon, which means there's 12 sides. Each side has a length of 3 feet, so the total perimeter of the 12gon would be 36 feet. Number 43. A speed of 60 miles per hour is equal to 88 feet per second. So 60 miles per hour equals 88 feet per second. If the speed limit in a school zone is 15 miles per hour, what is the speed limit in this zone in feet per second? So I'm just rewriting the information down here. That's a super solver strategy. And now I'm going to look to see if there's a relationship I can use. There is, because 60 divided by 4 is 15. So therefore 88 divided by 4 will get me the answer I'm looking for in feet per second, which is 22. Alright, number 44. How many divisors of 64 are perfect squares? Well, this problem has vocabulary that we need to know. First, divisors. Another word for divisor is factor. So what are the factors of 64? The best way to list factors is to list them in pairs so you don't forget any. So let's do that. 1 times 64, 2 times 32, 4 times 16, and 8 times 8. So there's 1, 2, 3, 4, 5, 6, 7 factors of 64. How many of them are perfect squares? Well, perfect squares are numbers that have a whole number square root. Another way to think of it is numbers you can get to by squaring a whole number. So 1 squared is 1, so 1 is a perfect square. 2 squared is 2. Sorry, 2 squared is 4, so 4 is a perfect square. 3 squared is 9, so 9 is a perfect square. Well, what are the perfect squares we have over here? 1, 1 times 1. 4, that's 2 times 2. 16 is 4 squared, or 4 times 4, and 64 is 8 times 8. So 1, 2, 3, 4. There are 4 of these divisors that are perfect squares. Number 45. If AB equals 2C, BD equals C, B is not equal to 0, and D equals 16, what is the value of A? So I like to call these problems alphabet soup problems. First, let's take, if we know any values, let's take them and plug them in, and we do. We know that D equals 16. So let's take that and plug it in over here. 16 times B equals C. If D is 16, B times 16 equals C. I just flipped around the order, 16B. And I see that right here, right, we have an equation that's set equal to 2C. AB equals 2C. So let's double this equation right here. Let's multiply both sides by 2 so that we'll have it equal to 2c on the right. So 16 times 2 is 32. So 32b equals 2c. And now we can set the left sides of each of these equations equal to one another, because look, we have 2c and 2c. Well, 2c is equal to 32b. It's also equal to ab. Therefore, 32b and ab, those must be equal. And if 32 times b is equal to a times b, then a must be 32. 32 times b equals a times b, so a must be 32. And that's what we were asked to find in the problem, the value of a. That was definitely worthy of its 3-star rating. Number 46. All of the streets in Tom's city are on a regular rectangular grid and run east-west or north-south. Tom starts at the intersection of Points Avenue and 11th Street and walks 2 blocks east, 3 blocks north, then 4 blocks east, then 5 blocks north. Tom then returns to his starting location by walking 6 blocks west and 8 blocks south. What is the area in square blocks enclosed by Tom's path? So we're asked to find this area inside this irregular shape. So a lot of times you'll learn that to do this you can split the shape into 2 rectangles and then add the areas of those rectangles. I like to use this other method, which is a cutout method. So I'm going to extend with a dotted line down here to make a full rectangle. And if we look at this full rectangle, that would be a 8 by 6 rectangle, right? So that would have an area of 48 square blocks. But we don't have that full rectangle because this corner piece is not part of the area we're looking for. This corner piece has been cut out, has been eaten away. And the area of that corner piece is 3 times 4, which is 12. So let's subtract that away from 48, and we'll get the area of the blue shaded space, which is the area enclosed by Tom's path. So that's 36 blocks. Sorry, 36 square blocks. All right, number 47. This is just a cruncher, a number cruncher, right? We're just going to have to do the calculations. So let's do the numerator first by getting a common denominator. That's 3 6 plus 2 6, that's 5 6. On the bottom of the fraction we have 5 20ths minus 4 20ths, that's 1 20th. And then I rewrote this problem as division because that's what that big fraction bar means, division. And we can use keep, change, flip to change this to multiplication. We get 5 6 times 20 over 1. Now we'll cross simplify. 6 and 20 can both be divided by 2 because they're both even. We get 10 and 3. And our final answer is 50/3. When they say express your answer as a common fraction, they want it as an improper fraction, not as a mixed number. So 50/3. Number 48. Back-to-back fraction crunchers. Boo. What is the arithmetic mean of 2/3, 7/9, 1/4, and 5/16? Express your answer as a common fraction. Well, arithmetic mean is synonymous with mean. They just want you to find the average. So let's add up these 4 fractions, and then we'll have to divide by 4. So right here, that's going to be, I'm going to add these 2 fractions first, because 2/3 is equivalent to 6/9. So 6/9 plus 7/9 is 13/9. Then let's add these 2, because 1/4 is 4/16. So those add to 9/16. Now we got to add these together, and we got to get a common denominator. Unfortunately, the smallest number that 9 and 16 can both go into is 9 times 16, which is 144. So we're going to get 81 over 144 for this fraction. And for this one over here, we're going to do 13 times 16. 13 times 13 is 169, and then 13 times 3 is 39. So 13 times 16 is going to be 208. We add these 2 fractions, we get 289 over 144. And now we have to find the average. We've added them, and we now have to divide by 4. Well, dividing by 4 is the same as multiplying by 1/4. So I'm going to just go straight to multiplying by 1/4. And I know that 289 can't be divided by 4 because it's odd, so we're going to just multiply 144 by 4 on the bottom of the fraction and get 576. And that's our final answer. Number 49. If a and b are real numbers, such that a plus b equals a minus b, and a is not equal to b, what is the value of a squared b plus b minus ab squared over a minus b? The key on this one was to focus on this piece of information right here. If a plus b is equal to a minus b, the only thing b could be is 0. Because if you're adding something and you get the same value as if you were subtracting that something, it must have no significance. It must be 0. And now we can plug b equals 0 into this second expression, and it's going to make our life very simple because all this stuff is going to get canceled out. A squared times b would be a squared times 0, that's 0. Plus b, that's plus 0, we can take that out. ab squared is also 0, we can take that out. On the bottom, we're subtracting 0, so that's irrelevant. And all we're left with is a over a, which is 1. Any number divided by itself is 1. All right, finally, number 50. Given that 75% of a certain number is 88, what is 3/8 of the number? So let's use our knowledge that 75% is 3/4. So 3/4 of a number of a certain number n equals 88. Well, let's convert 3/4 to 6/8. So 6/8 of a number is 88. And if 6/8 of a number is 88, and we want to find 3/8 of the number, well, look, 3/8 is half of 6/8. So 3/8 of n will have to be half of 6/8 of n, and half of 88 is 44.